Okay, we have two inequalities here, very similar to each other. In fact, the only change is the direction of the inequality symbol. We want to solve these algebraically using a sign graph. Now, the first recognition is these are non-linear inequality, mainly because of the variables in the denominator, but also because we have a power of 2 or more. Either one of those things make this non-linear. To solve a non-linear inequality, first we need comparison to 0, which has been given to us, and then we need to factor. So here, x squared minus 2x plus 1 in the numerator, that factors as x minus 1 all squared. The denominator, 2x squared minus 7x plus 6, that's a trinomial. It factors as a 2x and an x at the beginning. And then I need a 2 and a 3, both signs a minus. This will give me my total of 7x in the middle. Okay, now once I have it factored, I find split points by setting each factor from the numerator and the denominator equal to 0. X minus 1, 2x minus 3, and x minus 2. Now I know the numerator has x minus 1 squared. Remember, this is the multiplicity of the factor. The factor itself is x minus 1, so I only need to set x minus 1 equals 0. So I get 3 split points at x equals 1, x equal 3 halves, and x equal 2. Very, very close to each other. That's done intentionally. We put split points on the number line in numerical order. Now I'm going to spread them out a little bit to give myself some room. This has divided the number line into 1, 2, 3, 4 different sections. And we need a test point in each of those 4 regions, not including these values that are split points. So this side's easy. Something less than 1, I'm going to pick 0. This side's also not bad. Something larger than 2, I'm going to pick 3. It's a little bit trickier is picking a number in between 1 and 3 halves. Now it might help you if you remember that 3 halves is 1.5. So if you want to think decimals, how about 1.2 or 2.5 or 1.3, whatever. And then something in between 3 halves or 1.5 and 2, oh, how about 1.7? Anything in between. Now again, this is a sign graph, so we are only interested in when we plug in our test points if we get out positive or negative quantities. So I'm going to start with 0. I'm going to put it into the factored form. In the numerator, 0 minus 1 is a negative, but then I have to square it, and that becomes positive. In the denominator, 0 minus 3 is negative, 0 minus 2 is negative. Positive and 2 negatives with multiplication and division give us a total of a positive quantity, whatever that number is. Now, it doesn't matter again what the number is, as long as you have something in this region, you'll always get a positive times a negative and a negative, which will give you an overall positive. Okay, now what about 1.2? 1.2 minus 1 is positive. Square it, I still get positive. Alright, now here you might have to think a little bit. 2 times 1.2. If you need to, use a calculator, but that's 2.4 minus 3. That would be negative. Here, 1.2 minus 2. That's also negative. Positive and negative is a positive. Okay, next region, 1.7. 1.7 minus 1, square it, that's positive. 2 times 1.7, that's 3.4. Minus 3, that's positive. 1.7 minus 2 is negative. Positive, positive, and negative with multiplication and division is negative. And finally 3. 3 minus 1 is positive. Square it, I still get positive. 2 times 3 is 6. 6 minus 3 is positive. And 3 minus 2 is also positive. And of course all positives give me a positive. Okay, so now this is an example where the signs do not all alternate. We have 2 positives right next to each other. We did get some of our split points from the denominator, and because we can never divide by 0. The places where the denominator, only the denominator, gave us split points, I want to put open circles on my number line to help me remember to not include these values no matter what. Okay, now using the sign graph to answer the inequality, I want values that when I plug in, I get greater than or equal to 0, which is my positives. I have 3 positive regions. Okay, the equal to in general means include your endpoints unless it came from a denominator. So my first endpoint for my regions at 1, that one I'm going to be able to include. So let's see, negative infinity to 1 with a bracket. Then I have a plus region that starts at 1 and goes to 3/2 with a parentheses. Then I have one more region that starts at 2 with a parentheses and on out forever to infinity. Again, I have to use parentheses at the 3/2 and the 2 because those split points came from denominators and I cannot divide by 0. Okay, now this would be an acceptable answer. If you really want to give the best form though, notice that these two regions, because we're including the 1 in both of them, those can be joined into one region to give us negative infinity to 3/2 with a parentheses, and the second region of parentheses 2 to infinity. Set notation for the union if you want it, you don't have to use it. Okay, and again, either one of these forms will be fine as far as I'm concerned. Okay, now, this last one has a little bit of a twist to it. It looks very similar to the original, and in fact, because the factoring is going to be the same, split points are going to be the same, we're going to get the exact same sign graph. So let me just copy it. The sign graph is still going to be this. Still can't include 3/2 or 2. Plus, plus, minus, plus. And this time we want, after we plug in, to get things that are less than or equal to 0, which means the negative region. It's right here. So there's only one region. It looks like this should just be parentheses 3/2 to 2 parentheses. But there's a twist. The twist is this includes an equal to. And if you look back at where the split points came from, when the numerator is 0, that's the value of 1. So x equaling 1 makes this quantity 0. And we have to include it separately. And you can't pick that up from the intervals, again, because this is one that has 2 pluses right next to each other. So if the signs don't alternate, sometimes you get these little oddities, like in this case. So I do get negatives from 3/2 to 2, but I do get the situation where I equal 0 separately at the value x equal 1. And that will just list as its own x equal 1. So all of this is the solution to this second inequality.